If the valence electrons of an atom participate in covalent bond formation, being part of the bond, they are called the bond pair. They are shown as a dash holding two atoms, and in Lewis structures, they may be denoted using two dots for two electrons. For example, a Cl2 molecule may be denoted as Cl-Cl or Cl"Cl. The bond pair indicates an atom's stability since each atom forming the bond attains octet electron configuration in its outermost valence shell by electron sharing. If the bond pair of electrons is part of a polar covalent bond, it may participate in covalent bond breaking and bond-forming chemical reactions. A bond pair linked to highly electropositive metals like boron, aluminium, or lithium can act as nucleophiles in reactions. On the other hand, lone pairs are those valence electrons of an atom that did not participate in a covalent bond formation reaction and thus remain unused. They are denoted as two dots for two electrons above the atom symbol. Amongst the p-block elements forming covalent bonds, nitrogen, oxygen, and halogen have 1, 2, and 3 lone pairs. Lone pairs are nucleophilic because they are electrons by nature. This means they can undergo covalent bond formation with other electron-deficient counterparts. Now, if the bond pair of electrons, which holds two atoms together and belongs to both atoms, breaks equally in a way that each atom gets one electron, a free radical is formed. This newly formed free radical is denoted with a dot over the atom symbol. Despite retaining one of the bond electrons, the atom loses one of its shared electrons, making free radicals electron-deficient species. This makes them highly reactive, unstable, and more prone to undergoing addition type of reactions. In one sentence, when an atom's valence electrons participate in bond formation, bond pairs are formed. When they do not participate in bonding, lone pairs are created. And when the covalent bond holding the bond pair breaks equally, it leads to the formation of free radicals. To learn chemistry with Sibi, subscribe to Curly Arrows Chemistry.